Assalamualaikum and good day to you all. My name is Nurshafanina Binti Azizul. For today, I will present my FYP project entitled Vibration Assist Electrical Discharge Coating EDC on the mild steel with the inclusion of the titanium oxide powder. Surface modification technique has a huge capability for workpiece modification to repair and improve the workpiece properties, especially for the corrosion resistant, wear resistant, high temperature resistant, and improve the hardness of the coating layer surface. There are many types of surface modification, but for this study, the EDC process will be chosen in order to improve the workpiece properties. The surface modification of EDC is conducted using EDM die sinking machine by converting the polarity of workpiece and electrode. EDC process requires the presence of dielectric fluid to coat a workpiece surface with an electrode and fluid within a short time. The EDC process consists of two major methods, which are powder suspended method called PM-EDM and the second is PM electrode. Next, to avoid the sedimentation of powder during the process, the ultrasonic vibration will be applied during the process. There are three types of vibration that are commonly used, which are applying the ultrasonic vibration in the dielectric fluid. The second is applying the ultrasonic vibration at the electrode, and the lastly is mount ultrasonic vibration at the workpiece. The problem statement for this study is focusing at the mild steel. As we know, mild steel is a versatile material which is widely used in engineering applications such as automobile component for the engineering facilities, pipeline, and the building bridge. The mild steel properties contain a low hardness because it has a least value of the carbon content, and it will lead to the accumulation of the hydrogen in the steel that can cause the oxidation of the metal. The major problem faced by using the mild steel is it easy to be corroded when exposed to the environment due to degradation of the metal, and it will result in equipment failure to be operated due to the rusting. Next, the problem faced during the machining is the agglomeration of powder even applying the stirrer system, and it will lead to the abnormal discharge such as arching, cause the debris to be attached on the machine surface and cause a surface defect, so it will affect the properties of the workpiece after the process ends. The objective of this study is to investigate the effect of the amplitude and the frequency of vibration during the EDC process of a mild steel with the inclusion of titanium oxide powder suspension. Second is to compare the effect of the machining response with and without the assist of the vibration during the machining process. This is a scope of this study. The method that has been selected for this study is the PM-EDM method. PM-EDM or powder suspension method is about the mixing of the powder into the dielectric fluid to form a mixture. The suspended agent that has been selected is a titanium oxide powder. This is due to its characteristics, which are contain high hardness, high abrasion resistance, and high melting point. It also has high thermal expansion, which can prevent the excessive stress strain, which can cause a rusting. In this process, the ultrasonic vibration will be applied in the dielectric fluid during the process to avoid the sedimentation of the powder and to improve the machining process. The workpiece that has been selected for this process is the mild steel, and the electrode used is the copper rod. The machining parameter that will be varied is a frequency and the amplitude of the vibration, and the rest will be same. Lastly, The machining response that will be analyzed are surface roughness, layer thickness, surface hardness, and a layer composition. This is a literature review for the surface modification. The surface modification of EDC is using reverse polarity, which are the electrode is placed at the anode, while the workpiece is placed at the cathode. The material removal rate will be increased when the electrode at the anode, and it leads to the high deposition rate of material to the workpiece surface. The advantage using this EDC process is it is low cost compared to other surface modification technique. Then, EDC process also easy to be operated. Third is EDC provide a higher degree of the hardness on the material surface. Lastly, it able to produce a hard and wear-resistant coating. Next, this literature review is focused on the vibration. What can I conclude from this previous journal is the ultrasonic vibration can evacuate the debris between the workpiece and the electrode by bubble cavitation. It will lead to the increase in discharge energy spark. More material will be transferred to the workpiece and can produce strong coating surface. Next is ultrasonic vibration also can enhance a better flow of a dielectric fluid because it can prevent the powder agglomerate below the tank. By applying the suitable amplitude and frequency of vibration, the material deposition rate will increase and better surface properties will be achieved. Lastly, by adding the titanium oxide powder, the surface roughness and the machining time can be reduced. Hence, the workpiece properties will be increased. This is the methodology of this study. The flow chart is show the working flow of the experiment. The experiment begins with the preparation of the electrode and the workpiece. For the copper electrode, in order to get a flat surface, the copper rod should be ground and polished by using grind and polishing machine. I attach 320 grit of sandpaper with a 300 RPM speed. For the workpiece, it should be cut into a proper dimension. Then, continue with preparing the mixture. The kerosene oil will be mixed with the 10 gram per liter of titanium dioxide powder concentration. This combination will form a dielectric fluid. The machine used to prepare the mixture is a labosonic ultrasonic homogenizer. Then is define the parameter. The parameters such as peak current, voltage, duty factor, the powder concentration, the pause on time, and the pause off time is keep the same. While the parameter that will be changed is the frequency and the amplitude of the vibration. Next is continue with the vibration preparation. The ultrasonic vibration will be applied in a fluid in order to distribute powder uniformly and prevent the agglomeration of the powder. The machining parameter change for the amplitude is 0, 2, and 6 micrometer, and for the frequency is 0, 20, and 50,000 Hz. After set up the machine, the EDC process will be begin. This EDC process will be conducted using EDM die sinking machine. The workpiece electrode should be immersed in a dielectric fluid during the process. After finish the process, the workpiece should be measured and analyzed. Before that, the workpiece should be cut into a small pieces and remove the debris at the upper part of the workpiece. Then, measure and analyze. Firstly, check the surface roughness by using surface roughness tester. Second, check the surface hardness by using Vickers micro hardness tester. For a layer thickness, we can use a SAM, and lastly, layer composition by using XRD analysis. Take each reading at 3 different points to get an average value of the reading. Lastly is the expected result from this study. Firstly is the better surface roughness, layer thickness, surface hardness, and the layer composition can be achieved after applying ultrasonic vibration with PMEDM. When applying the ultrasonic vibration assists the fluid, the powder will distribute uniformly, and lastly, no powder will agglomerate below the tank. That's all presentation from me. Thank you and Assalamualaikum warahmatullahi wabarakatuh.